today we'll try to solve few problems based on array itself. That is nothing but the combination of array, then loops, and a bit of function. Okay, so the problem name is something as pairs in array. Pairs in array. Okay, to understand this, I'll just have a pair. For example, let's say 87, 5, 1, 2, 63, 70, something like this. I have a simple array. Okay, now what is the pair here is nothing but like once I take the first element, let's say 87, then I want all the combinations of this like 87, 55. Okay, then the next pair will be 87, 1. Then the next pair will be 87, 2. Then 87, 63. Let's have the pair up to 63 itself. Let me remove this. Okay. Then once I get this, so this loop is done. This pair is done, right? The 87, all the possible things are completed. Then we'll shift to the next number. Let's say 55. Then all the possible combinations of 55. For example, after 55, we have like 55, 1. Why don't we take 50, 87? Because that is already covered here, 87, 55. So we have to just ignore it. So all the numbers which are ahead of this. So we have 1, 2, and 63. So 55, 1 is already done. So 55, 2 has to be done. And then 55, 63. No? So once we do this, then 55 is also completed. Then we shift to one number and it has only two pairs, that is 1, 2 and 1, 63. So 1, 2 and 1, 63. Similarly, we have to do it for 2 and 63. Here. So this is the problem statement. You can just pause the video and try to solve it on your own. If you are able to get it good, or you can always refer back. Okay. So yeah, I hope you have got it. So if not, let's try to see. Like first, let's try to understand how this will work. So if by seeing this logic, what I am getting to know is that first of all, we require one loop. What is the task of this loop is to just switch from one number to the other, like 87, then it will go to 55 and 1. This is nothing but to get the first number. So our starting pair. So here, if you see the starting is 87, everywhere is 87, right? So here everything is 55. So to get the starting number, we want a loop which will help us to switch between the numbers. So it is the 87, 55, 1, then it will be 2, and at last it will be 63. Okay. So one loop will help us to go like this. Okay. And after getting this, what we observe one more thing is that after getting any number, there is one more internal work happening that is also being repeated continuously. For example, now if I take 55, so once I get 55, I have to go again to 1, 2, and 3. So if you see, like here also there should be some loop which will help me to go to the next number. Same thing for 1. If 1 is the main target, after 1 I again require one sub loop which will help us to give 2 and 3. Okay, so I can say something as this is the main loop or the vertical loop I can say, and I can say one more, there is a sub loop which will help us to go in the horizontal loop. Okay, sounds good. Okay, let's try to practically do it now. So what I'll do is let's clear the screen and let's try to have the array first. So I'll create an array, like let's say int ARR square brackets. I'll store some random numbers here. Let's say 45, 85, 65, 32, 55. Okay, it's repeated. Let's say 64. Once I have this pattern, this many numbers, what I do is close it. And let's create a function. So I'll say public static. Okay. Do we want to return something? For presently, not. Let's try to just display it in function itself. So I'll do void. So we don't want to return anything. Then what's the function name? Let's say function name is pair in array, something like that. Okay. Do we require any arguments? Yes, obviously we are saying we want this array, right? Okay. So we require the array. Then after that, yes, that's it. Now coming to our logic. So what we first discussed that we want to loop. So for, and this loop should start from 0th index and go up to the last. So let's say start with 0. So I'll say int x equal to 0. Okay, started with 0. And up to where it should go? X dot, x less than whatever is the array dot length. So once I've done with this, now if I print it, what it will print? South. If I just print x, it will just print the index, which I don't want. You see what happened? Oh, yes, obviously I didn't call it. So let's call it. So pair in array. Pass array in this. And let's run now. Okay, cool. I got all the index values, which I don't want. What I want is the array, right? So I'll say I'll pass this index values in the array like this. And if I run now I'll get all the values, which we have discussed multiple times. So once I get this, what I want one more loop, which will start from next number up to the end. Okay, for int y. Okay, where should this y start? For example, now your x is 87. Where should your y start? Y should start from 65, right? So if x is 87 and if you want to start with 65, that is nothing but what it is, x plus 1, right? So start from x plus 1, where is x plus 1, and go up to where? Up to the length. So same logic here, array dot length. Control C. I'll say y should be less than array dot length and y plus plus. Clear. So once we have got this loop, now what we'll do is let's try to just display it south. Okay, obviously what we want to travel in horizontal way. So I'll remove this ln, so that is printing in horizontal way. And how I want to print, I want the parentheses also, and then I want the x value and y value also. Right. So if, for example, let me reverse it. So here, let me close this. So here, if you try to observe, where is the pen? Okay. What's happening here? This 87 is what? 87, 87, 87. These are nothing but the value of x, right? These are x, x, x. Here also 55 is what? 55 is the value of x, x. And what is these values? The next numbers, second numbers are nothing but the y value, which we are getting with the help of y loop, right? So obviously what I want is I want this x comma y, right? So let's try to quote it here. So obviously if you want to print parentheses, you have to give it in quotation mark. Okay, then I want plus, what is the next value? X, okay, plus what is the next value? Comma. So okay, then plus what is the next value? Is y. Then plus what is the next value? Close parentheses. Close. Okay, will it work? Yes, it should work. The only thing is that here we are doing print, so it will always go in horizontal way. However, we have here ln, which will take it to next line, but it will be not that accurate. So for that, what I'll do, that whenever our one horizontal line is completed, I'll keep a new line with the help of south print ln. And yeah, that's it, I guess. Let's run it. Cool. So, oh, okay. Again, the issue is what? We don't want to print the index. We want the value of it. So let's take the value. So Control C. I'll pass whatever the index value is in the array. And same with the y value. Clear. So yes. Okay. Hopefully it should work now. Cool. So let's see if it is correct. So we have 45,87. Okay. Then 45,65. Clear. 45,32. Very good. And at last 45,64. Yep. And at last, what would be the last pair? That is nothing but 32,64. Clear? So if you don't want these intermediate numbers, then you can just simply delete this part. And then if I just run it, we'll just simply get the correct pair. Clear? So this was something known as pairs in array. Cool. And this required a 2 loops. Now let's try to level it up. So what we'll do now is we'll try to print all the sub-arrays in the loop. For example, let me take the same array, and here what I want is my next question would be sub-array. Sub-array. So from this, what I have to first get is, let's say my first sub-array is 45, 87. This is one array. Then my again next sub-array is 45, 87, 65. Good. Then my next sub-array is 45, 87, 65, 32. Okay. And the next array is nothing but the entire array. Clear? And next time when it will go, it will start with again 87, and then it will start with 65. Clear? Okay, this is good. Then we'll start with 87, 65, 32. Good. And at last we'll be having 87, 65, 65, 32, and 64. Yeah. So the same logic, but here what we are doing, instead of just printing two pairs, we are printing the entire subarrays. Okay, so it will start from here, then this combination of all this. Yeah. Cool. So this is the problem statement. Again, you can pause the video, try to solve it on your own. If you get it, well and good. The solution is here itself. Yeah. Okay, good. So how to approach it? Okay, let's try to write it once. So first of all, what I require is one vertical loop. Let's say that you can call it main loop also, but I prefer to say vertical loop. Okay, because we are going in down direction, right? So what this vertical loop will do, this will give me the main numbers. Let's say 45. Then it will give me 87, then it will give me 65, then it will give me 32, and at last 64. Yep. Okay. Now what next? So I want a loop here which will tell me the index values. For example, it will give me the so it should basically the same loop what we have used here, the same loop will be used, which will give me the index value. So first it will give me the index value of this, that is nothing but 1. Then it will give me the index value of this 2. Then it will give me the index value of this 3. And at last it will give me the index value of 4. So here, this loop will give me what? The index values. This is nothing but 1, 2, and 3, and 4. Right? So once I get these index values, my final loop is required. Final loop I can say, loop, which is a sub loop of this again. What should this do? This should take the starting point as my x, whatever is the x. So this will take the starting point as x, and the ending point, what it should take? First, it should take 1. So first it should take 1 as the ending point. Second, it should take 2 as the ending point. Third, it should take as 3 as the ending point. And fourth time, it should take 4 as the ending point. And it should simply print it. So this loop work is just to print. Clear? So with the first loop, we are getting something as starting point, we can say. Good. With the second loop, we are getting all the ending points, we can say. Good. And with the third loop, we are just printing. Clear? Okay. If it seems confusing, just writing a code once will make it much more sense. Okay. So let's try to write it. So let's clear the drawing. Done. Okay. So for this, again, I'll create a simple function. So let's say public static. Do I want to return? Presently not. I just want to display. So public static void. What I want to do? Name. Okay. Naming is the huge task. So what should I name? What is this? Subarray, right? Okay. Subarray. Okay. Do I need any arguments? Obviously, I want an array. So good. I'll take the array. Then anything else? No, fine. So let's start with the first part. So first part is again going from starting point to ending point to get the vertical this. So a simple for loop for int x equal to 0. Okay. X should be less than what it is, array dot length. Okay, good. And then keep on updating my x. Great. So we got a first x value. Then what will be my second loop? my second loop should obviously, like if I get now 45, it should obviously start from like 87, right? So, okay, so for this, I'll write a condition for, let's say, int y equal to always one extra, right? So I'll say x plus 1, okay? And okay, go up to where? Even this should go up to the last point. So I'll say array dot length. Length. Okay, and keep on updating my y plus plus. Great. And if you just stop a moment here and just compare it with the previous code, this is nothing but the same logic. If you see whatever I have written here for pair in array, if you have understood this concept, then subarray is almost same. Okay, only the extra part what it is will come now. Okay, so what did we discuss previously? Like let me just bring back the here. So here what we got to know is our main loop. This will give us what? Starting point. Okay, and our sub loop. Where is the sub loop? This was our second loop, and this was our third loop, right? So our second loop is giving us what? Ending point, right? So with this knowledge, what I'll do is I'll create my third loop. Okay, so let's write it here. So my third loop is for, let's say, z, int z. So equal to, where is my starting point? X is my starting point, and z should be less than where? Not only less than, even equal to should be considered, right? Because we want to take the consideration also. So let's take equal to, like equal to what? The second loop value, that is y. Okay, let me take y then, and keep on updating my z plus plus. Great. So once I do this, okay, now the last final task is to print it. So I'll say south. Obviously, I don't want ln here, so I'll remove the ln. And here, what I have to print is basically a z itself, nothing else. Let's see, z. And what I'll do, once like if this is a continuous horizontal line, and after every horizontal line, I want a new line. So let's do a new line, and let's call this function below. So I'll just replace it with the previous function, and let me clear the mess and run it. Cool. We got something very unique. So the issue now here is, first of all, instead of z, what I have to do is I have to give this array of square bracket, control C and control B. And here I have to give empty square bracket. Now, let me just bring back the drawing here, what I had drawn. Okay, so here what has happened now, these all values, whatever I am getting, okay, these are like end. This will be with the help of this loop, right? So this entire thing should be my horizontal part. Am I right? Think once again. This is my second loop. Okay, let me just draw this. This is my second loop. This is giving me nothing but 1. And my third final loop, south, what I am doing is using this part. Okay, so where should I actually put my print statement? That is once my second loop is completed, because with the help of second loop, we are going horizontal. This is nothing but giving us the end point. So what I'll do is I'll just call this println statement after the second loop. So if you see, this is my second loop. If I just minimize it, you can get it. Okay, so after my second loop, I'm printing a new line. So let's see now. Run it. Cool. So it worked completely fine, but there is a lot of mess. So to differentiate it, what I'll do is after every z plus, I'll say a blank space. Oh, wait, sorry. Where did I give? I should, plus a blank space. Okay, cool. Check it. Okay, it looks different. They are separately spread, but it's still not that satisfying, right? What we wanted is somewhere parenthesis, having a parenthesis bracket would make it a bit good, right? Now, where to place the parentheses? What we know is this is somewhere that is a single subarray is being printed, right? So this will be like start and end. Then after this, we are getting a new start and new end. And this is still in the same this start and end. And here at beginning, there will be a small start and a small end. Okay. So this part is happening here. Okay. And once this part is completed, when it goes back to this main for loop, we are getting a new end. And again, whatever the task we have done here is being done here itself. Okay. So obviously, I know before starting this, I have to give this thing. So what I do is I'll give it here. That is after this loop, like before this loop. So what I'll do is south. Okay. And I don't want to print it in new line. I will just write like this. And I'll say like this. Okay. And obviously, no, once I have like start and end is completed. So I want this end parenthesis. So that is nothing but once I complete this loop. So here I'll say south and the end parenthesis, I'll give it here. Clear? And once this entire part is being completed, that is this entire for loop is completed, we have a new line. Let's check it if it works fine. Cool. And I have mistakenly given here ln. So now it should work properly. Good. So if you see, yep, we just achieved our target. Am I right? Yes. So if you see, it's like 45, 87, then 45, 87, 65, good. 45, 87, 65, 32, very good. 45, 87, 65, 32, 64, very good. And at last we have 32, 64. Yeah. So I hope that's it. Like you have understood the problem. If not, just try to go through it once again. I feel like only this part will be a bit confusing, if not yet clear. Okay, just try to put it with the help of paper and pen. Try to do it once and it will be completely. Okay. So the next question is to calculate the max sum of a given subarray. Okay, so we already have a function. Just we discussed previously, like how to get the subarray of all. So each subarrays will calculate the sum, and whichever is the max sum, we are going to return that. Okay, so for that, I already have an array. Let's say the array is, so I also included few negative numbers, that is -2 and -1 between. First of all, let's display this subarray. I have to call the function, right? So subarray. Okay, that's it, and run it. So if you see, okay, everything is working fine. Just we'll do a minor change. That is, we'll consider the one element also as a subarray itself. In our previous example, we didn't do that. What do I mean by that? Is, for example, here, the one. Let's consider one also, like a single element also a subarray. So for that, what I have to do is I have to simply remove this, what I have given here, x plus 1, as simply x. So initially, x will be also 0. And when at that time, y will be also 0. And our loop will run for only like 0, like 0th index. Okay, when this condition is achieved, and if I run it now, cool. So if you see the starting element, I got 1 at a time, 1, -2, 6, -1, and 3. Okay, and the ending is same. Okay, so we are just getting one extra subarrays. Now, once I get this, what I have to do is I have to calculate the sum of all the subarrays. For example, now here, the first line will be somewhat like this. So 1 will be like 1. Then if 1 - 2 is nothing but -1. Then 1 - 2, 6 is 4 plus 1, 5. Then the next one, this is nothing but 3, 3, 4. And coming to this one, this is 3, 3 cancels, 6 plus 1 is 7. Correct? So this is for first time. Similarly, we have to do for second line, third line, and fourth. Okay, once we do this, the max of this, presently which is max, this is the max. So if we don't find any max number here below, then we are going to return the max sum as 7. Okay, so I hope you have got the question, what we have to do. Okay, now coming to solution part, you can just pause the video and try to solve it on your own. The hint would be, you have to just do a minor changes here. Okay, Give it a try. If not, you can always come back. Okay. So now there are three approaches to solve this problem. Okay, starting with the basic to advanced one. The first one is known as brute. And I would like to call like brute force. Okay, so what will happen in this is that the entire concept what we have used for subarray, the same concept is applied here. Here, instead of just displaying, what we are doing here we are just displaying, right? So instead of displaying, what we'll do, we'll create a variable as, let's say, current sum. And here, whatever we are displaying, that will keep on adding to our current sum. Okay, in that way, we'll get the current sum for all the subarrays, and then we can just find out the max by comparing. So let's try to do that. So what I'll do is I'll just duplicate this part. So control duplicate. Once I have done, I'll change the function name. So that will be like max. No, it's a brute, right? So let's say brute. I can say. And here, what I have to change is I have to change this line. So I have to remove this. I first want to create a current sum as a variable. So int current sum, okay, equal to, let's say it's 0. Okay, good. Then what I'll do is I'll update my current sum. So current sum plus equal to what I have to update with. I have to update with my array z, which I'm displaying, right? So I'll just copy this array z and I'll keep here. Okay. So now I am not displaying it. I am just in fact adding it. Okay. So we'll get the current sum of each. But before going to the next loop, we have to also reset our current sum. So I'll say current sum is equal to 0. So that next time when it goes to the loop, again, the current sum is fresh. It's calculated fresh. Right? But is this the end? No, we have to calculate what? We have to calculate the max. So for max sum also what I'll do is I'll create a array which says max sum. Okay, which is also initially it will be 0 itself. Okay, so once I have max sum and before resetting the current sum, I'll just put a condition here. What condition I'll put is that if my current sum is greater than max sum. Okay, if this ever happens, what I'll do is I'll reset my max sum equal to my current sum. Okay. So I hope just a simple if condition, and after that I'm going to reset my current sum. Clear? Okay, cool. Do we require to display? No, we'll just return the value. So I'll change this to int, and at last of the main loop, I'll simply say return. What I have to return? Max sum. Clear? And okay, if you want to see what is there, so you can also see current sum. So if, for example, I'll do south, I'll remove the println, and here I'll display, let's say, current sum. Not inside the for loop, I'll put it outside the for loop. Okay, so it will keep on calculating and it will display the current sum. This will end the start the parenthesis, end the parenthesis. And yeah, okay, that's it. Okay, actually these printing statements are not required, but it is better to visualize like what is the sum we'll get to. Okay, so once we have done with this, so I'll just call the max array sum. Before calling, what I'll do is I have to require south because this is returning the value, right? So for that purpose, I said south, and then I'm going to say max sub array. Sorry, it's brute force, right? Brute force, and I have to pass what? My array. That's it. Clear? So let's put it to test and let's run it. Cool. So we got the output as 8. So let's see where is the 8 present. And okay. So here if we see 1 minus 5, 4, 7, what we had calculated initially. Okay. So the same thing we'll be able to see here. So it is calculating the subarray sum itself. And if we see the final one, it gave the output as 8. Okay, and that is present here, 6, 5, 8. So that is nothing but the combination of this subarray. That is 6 minus 1, 3. So let's see, 6 minus 1 is nothing but 5. 5 plus 3 is nothing but 8. Yes? Good. Great. Did we get it? Yes, cool. Let's try to give some print statements in between. So it's displayed properly. Here I'll say about an empty line. And here also after this, I'll say about empty line. Okay, and if I run it, it's still same, nothing much changed. Okay, good. The main logic, like if we try to observe our brute force, in brute force, we have seen that there were 3 loops here. Okay, and like if we consider the time complexity, here it is nothing but n cube. How n cube? Because let's say first loop is running for how many times? N times. And each time it is running, the inside loop is also running for n times. And inside this, there was one more loop. This is also running for n times. So finally, when we combine it, the time complexity for this is n cube. Yeah, obviously we have not yet discussed time complexity and space complexity, but you may get a general idea like how it's worked, right? But in prefix, what happens is it's a better version than brute force, because here we are completely avoiding a nested for loop, which is the third loop, which will be running for n, right? So how is it possible? For example, let me take the same array what I have here. So my initial array is 1, minus 2, 6, minus 1, and 3. So once I have this array, what I have to do is I have to calculate my new array known as pre-array, I can say pre-array. Okay, and what it will do, it will calculate. So this pre-array is nothing but it will calculate all the initial sum of all the values before it. For example, if I take the index of this, all the summation values before this up to 2. So for example, let me do it. So for first one, there is nothing to add here. So the value will be same 1, comma. Now, when I reached this index, I have to calculate all the sum before this, and I have to store it here. So that is nothing but minus 1. Then once I reach this point, I have to calculate all the sum from here to here. So that is nothing but minus 4, 4 plus 1, 5. And this will be 3, 3 plus 1, 4. And finally, we know this one is 7. Correct? So once I get this pre-array, my third loop that was present in this brute force can be completely avoided. Okay, which is present here. This can be completely avoided. Why? How? For example, with the help of brute force, what we got to know, our max sum is 8. And this was with the help of which array? It was with the help of the array 6, minus 1, 3 subarray. Okay, subarray. Now, what is the logic for prefix array then? So for the prefix array, the same thing what we have done here. We just required the starting position and the ending position. So here the start index was what? 0, 1, 2, 3, 4. So the starting index was 2, ending index was 4. So for prefix, what we can do is prefix array, whatever we have, the ending position of that end, that is nothing but square bracket of 4 minus, I'm writing prefix, and again prefix starting position minus 1. Start minus 1. So what is the starting position? Here it's starting with 2, minus 1 is nothing but we have to take the 1 here. So prefix of 1. And if we see what is present in prefix subarray of 4, that is nothing but 0, 1, 2, 3, and 4. Here, if you see, the value 7 is present. Okay, 7 minus what we have to do? Prefix of 1. That is nothing but 1 present here. And this is minus 1. So minus minus it will become plus, plus 1, 7. And finally, we get the output as 8. Clear? So instead of here, what was happening in brute force? Here we are having a loop. Am I right? Here we are having a loop. We are starting with 6, where our starting position was 6. Then we are going to -1. Then we are going to 3. And each time when we are going to our next this, our sum was getting updated, right? And finally, we had got the value as A. But here what we did it with the help of just one single value. That is with the help of end, whatever is there, we have just minused it with the starting position -1. Clear? Okay, so that is how we completely replaced a loop, nested loop. So let's practically do it. So here I'll write the prefix array now. So I'll create a new function for this. Here what I say? Public static. Do I need to return something? Yeah, I want to return max sum. So I'll say int. What will be the name? Let's give it prefix itself. Prefix array. Awesome. Then what is the this? I'll say int. I'm putting argument or parameter as an array. Good. And after that, inside this, first of all, what we discussed, we require a array. So let me call this array as pre-array. Okay, and I have to obviously declare it. So int pre-array and square brackets equal to new int. What should be the length of pre-array? So whatever is my array length, the same length should be there. Good. So once I declare my pre-array, next what I have to do is I have to fill this pre-array with the values. And I know whatever the first value will be the same itself, because there is nothing before that to add. So I can say like this, pre-array of 0 is nothing but array of 0. That is at least for sure. And once I get this, now I require a loop so that I keep on updating the next values of pre-array. For that, I'll write the loop for, let's say, int x equal to 0. And start, so no, we have to not start with 0, because we have already filled the value of 0. So here I'll start it with 1. And once I started it with 1, I have to go up to its less than array length, array.length, and keep on updating the x value. So x plus plus. Once I have done this, what I have to do now is I have to fill the pre-array square bracket of x. So values will be updating like 1, 2, 3. And what should I update here? The initial, whatever is initial before this. So that can be written like this, pre-array x minus 1. So I'll get all the initial values. Plus, what I have to do is array of, what is array of x? Okay. So with the help of this loop, what is happening? Our pre-array is getting filled. Now what I want is I want the starting position and the ending position, right? The values index. So with the help of that, we can calculate our max sum. So for that, starting position and ending position, I'm copying the same thing what I have here. I'm just ignoring the inside part from the brute force. And let me update my prefix here. Okay, so x is starting with 0. Okay, x up to array of length. Good. And y equal to this. Very good. So here, let me close it first. Good. Once I have this, I have to create a variable to calculate my sum. So for that, what I'll do is int sum. I can say current sum equal to, which is 0. Okay, and int max sum equal to, let's say this is also 0 for as beginning. And here I am simply going to say, first of all, I have to calculate my current sum, right? So what was the formula for current sum? We had seen. So current sum equal to my pre-array starting position. Starting position is what? X, we know. Control C. So first we have to give the ending position, right? So Control C. Y is my ending position. Y minus pre-array. Starting position minus 1 we have to use. That is nothing but x minus 1. So here it will be x minus 1. Correct? Clear? Everything is fine, but there's a slight issue. That is, let's imagine when we are starting our first loop itself, first this, when that time our x value is what? 0. And here if we see 0 minus 1 will become what? Minus 1. And we know there is no negative index. So obviously this will get failed here. So for this, we have to write a condition. That is, so here I'll put a ternary operator. So that is nothing but when my x equal to 0, check this. If this ever happens, what you return is pre-array square bracket of x. Return this. If my x is not equal to 0, then return this calculation part. Clear? Through this, what I am getting? I am getting my current sum. And once I get my current sum from this loop, here I'll check my max sum. So let's write the ternary operator for max sum also. So max sum equal to, I have to check the condition first. So what's the condition? If my current sum is greater than my max sum, if this ever, first of all, check it. If this is true, what you do is update the max sum as current sum, or update what? Update max sum. Correct? And close the run. So with the help of this, our max sum is getting checked and updated. And finally, what we'll do is we'll return the value here. So return max sum. Correct? So here I have written void. I have to change it as n. And let me clear this part. Okay, cool. Let me comment this brute force. I don't want brute force to be executed. And here I'm simply saying south. South. And inside this, what I have to call is my prefix function. Right? So prefix and parenthesis, I have to pass the array. Correct? So according to brute force, what was our max sum? 8. And even here we should get the answer as 8. So let's see. Okay, so if you see, we got our max sum as 8. Clear? And here, if you see, this is much more efficiently brute force. Why? In brute force, what happened? We had 3 loops as we discussed. This is the brute force, which is having 3 loops inside this, whereas in our prefix, we have just 2. And for few people, there will be a general doubt, like if you see here, even there is a 3 loops, like few students do ask me. But if you try to observe here, this loop is outside. So this is somewhat right. You can write this as n plus n square, whereas this is n cube. And when we compare, this is always less than n plus n square is always less than n. Right? Clear? Okay. So I hope you have got till here. So you have understood the brute force as well as prefix array. Now the next algorithm is Kadane's algorithm, which is much more efficient than prefix algorithm. Okay, which will run for only one time. So let's see how that works. Kadane's algorithm. Let's take an array which starts from like -2, -3. It can be anything, but I'm taking it in such a way that we will be able to see the exact working of it. -1, -2, and 1, 5, and -3. And as discussed here, in Kadane's algorithm, what we'll do is we'll be running the single loop. And therefore, we have to calculate the current sum as well as maximum sum in one loop itself. Okay, so here I'll be having a current sum, right? As well as there will be a maximum sum, which I'll write it. Right? And before starting, let's discuss a simple maths topic, like what Kadane has like observed. That is, whenever we use whenever we add 2 positive numbers, we obviously know the number will be a positive. Okay, that's fine. Whenever we have a big positive number and a small negative number, in this case also we know the last outcome will be a positive number itself. But in case if there is a small positive number and a big negative number, then in this case, the output will be a negative, right? And what are we calculating here? We are calculating a maximum sum. So here, Kadane said that in case if there is a situation where there is a small positive number and a big negative number, in this type, what you can do, instead of considering this as a negative number, you can just put it as 0. Right? For example, it will make much sense once we start writing this, like try running this. So if you see, let's say current sum, both are 0 itself. Because what we say, we saw that whenever it is a negative, we are just going to put it as 0. So initially both it is like 0. Then after this iteration, it is going to next loop. Okay. Here again, the current sum will be -3 because it's a negative number, and the biggest one is 0 itself. So we are updating like this maximum sum will be same. Then once this iteration is done and it moves further, here as soon as the current sum will be 4, because this is a positive number. So our current sum is updated as 4. And now we compare current sum and the maximum sum. The current sum is greater, therefore the 4 is updated here as maximum sum. Next, after this, what we'll do is we'll go to the next iteration. Here, our current sum will be updated. We have a big positive number and a small negative number. Therefore, the iteration, the summation here is current sum is 3. And if we compare this with our maximum sum will stay same. That is 4 because it is larger. Great. Then we move to the next this here. Now 3 minus 2 here it will be 1. Right? And the 4 it will be here still same. And after this, when we move here, our current sum will be updated to 2, whereas our max sum is still same because 4 is greater than 2. But as soon as I go to the next iteration, here our current sum is updated as 5 plus 2 is nothing but 7. Right? And when we compare this with max sum, which is greater, obviously our current sum is greater. Therefore, what we'll do, we'll update our max sum also as 7. Right? After this, what we'll do is we'll go to the next iteration. Your current sum is getting updated as 7 minus 3. 4. Right? Therefore, and what is our maximum? Maximum will stay same because this is larger. The 4 is less than 7. Okay. Therefore, as you see, I just use one iteration. That is, I'm just going one time. And in the same iteration, I was able to calculate both the current sum as well as maximum. Okay. And one thing to note is, in case if all the iteration, like all the numbers are negative, then you have to update your Kadane's algorithm. Okay. That would be a special case. Okay. Apart from that, it works for everything. Okay. So yeah, that part you can take it as a homework where you can update. So even for that, what we will do is we will have a simple loop which will first check if everything is negative. Then if everything is negative, the least one will be the max sum. Yeah, but that will not cover for time being. We'll just try to focus on this part. Right? So yeah, let's try to do this. So let me clear the screen and let me write the function here. So the function is like public static. We are returning the maximum, so int, and the algorithm name is Kadane sum, right? What I'm taking the argument, I'm taking the argument as int array square brackets. Right? And then here what I want is I require a loop first of all. So before that, I'll create two variables. So int current sum equal to, let's say it is 0. Okay. And int max sum is also equal to, let's say 0. Okay. Initially both are 0. Now here our loop will start where it will start with int x is equal to 0. Okay. It will go on up to x length is x array dot length. Okay. Then after that, we have to keep on updating our x. Right. So once we do this and once we enter our for loop, here first of all, what I say, my current sum is equal to is plus equal to whatever is array of x. Right. And once I do that, I'll put a if condition to check if the current sum is negative. So if the current sum is less than 0, then I'll first of all put this in a bracket. Current sum is less than 0. What I'll do is I'll make my current sum equal to 0. Right? After this if condition, what I'm going to do is I'm just going to update my max sum. So max sum, this maximum sum is equal to Here again, I have to check the condition. So here I'll say if current sum is greater than maximum sum, check it. Maximum sum, check it. So if it is true, update current sum or update max sum later. If not, then update. Let's write this also in the ternary operator format itself. So what I can say is current sum equal to, check if current sum is less than equal to 0 or less than 0. Then what I'll do, I'll check it first. Then if it is 0, then I will update it as 0. If not, then I will update whatever is the current sum value. Okay, and I'll just remove this line of code from here. Okay, so now I simply have 3 statements which will be checking here. And at last, what I'll do is I'll return the max. Okay, so if you see the code is very less here, but the logic present inside is very good. So let's try to test it. So I'll just comment this. I will pull it down, and what I have is Kadane's algorithm. Control C, Control V, Control slash, and let's check it. Let's change the array also. Oh, first, let's check on this. Okay, if you see for this, it shows the 8 as the output, which we have been checking it with the help of other algorithms also. So it completely works. Okay, so yeah, that's it with the Kadane's algorithms. So if we try to compare all, so let me pull out the brute force algorithm. Okay, and here we'll be having, let me show prefix and Kadanes. Okay, in brute force, what we did is we had n cube complexity, time complexity, n cube, whereas in the prefix, the complexity was somewhere like n square, and in Kadane's algorithm, we are having the time complexity as n. Okay, and all the return the same value when that is the maximum sum is 8. Yeah. So yeah, that's it with today's class. We'll catch up in next class.